down here, I forgot my headphones when I started this, and then halfway through or after a problem, I realized I didn't have them on. So again here, so we're using these two definitions. It's the same thing we did in 2.4. Nothing's different in this section here. So what it's saying is f of x plus h minus f of x. So that's what I'm doing number 2. I'll go back to number 1 in a second. So that means that wherever I see an x in this function, I'm going to put an x plus h. So it's going to say square root of x plus h. Again, so this means wherever I saw an x in the function, I put an x plus h. And then minus f of x, so write the function again, over h. So the only way to solve when you have a square root somewhere in the problem is to multiply by the conjugate. So remember, the conjugate means instead of a minus sign, there's going to be a plus sign here. So I'm going to do square root of x plus h plus the square root of x on top and on bottom. So remember, you never FOIL out the bottom. You always FOIL out the conjugate part. So this is going to give me the limit as x approaches 0. So when you FOIL out the top, it's going to be left with square root of x plus h times the square root of x plus h. And then the middle should cancel, and then you'll get x on the back. So now the top is going to cancel the x for me. So these x's will cancel. I'll be left with just an h. So the h over h should also cancel for me. So then we're left with the limit as h approaches 0 of 1 over square root of x plus h plus square root of x. So remember, at this point, now that we got rid of that h on the bottom, I can plug in 0 for h. So what this says is the square root of x plus the square root of x. So square root of x plus the square root of x would equal 1 over 2 square root of x. So the derivative of x square root of x would be 1 over 2 square root of x. Back to number 1 now. I already have the answer in here. So I'm using this formula over here now. So this is f of x. So I just wrote the function x squared minus f of a just means you put an a in the function wherever there was an x, and then over x minus a. So on this problem here, I had to factor out the top. So that's what I did down here. I factor, remember that's a difference of squares, so x minus a, x plus a. The x minus a is canceled for me. I was left with x plus a. Once the bottom cancels is when you make the x and a the same number. So we have x plus x here. So that's why I said that the limit was equal to 2x. For number 3, it doesn't matter if you use the a or the h one. So I'll just go ahead and use the h1 one more time just so you can see, because I think that one's a little trickier. But you do it the same. This is the same no matter which function you use. So I typically like the other one here, but I'm going to give you more practice on that one. So here we have 1 over x plus h, because you put an h wherever you saw an x, minus, it says f of x, so 1 over x, all over your h. So on this problem, we got to get a common denominator. So multiply this side by x plus h. This side's going to get an x. So I'm going to do the math down here, or up here, because you know I'm lazy. So it's x over x plus h, minus x plus h over x plus h. Remember that negative goes to both of those. So now the top really reads negative h over x plus h. I'm dividing my entire function by x. So instead of dividing by h, so instead of dividing by h, I can multiply by 1 over h. So those cancel. So I have negative 1 over x plus h. Once I've canceled the bottom, I can now plug in 0 for my h up here. So then it becomes negative 1 over x times x. So that tells me my limit equals negative 1 over x squared. Okay. The notes down here. So you could subtract all of this stuff out, combine like terms, and cancel it. That's totally fine. What I typically do on the AP exam is that I notice that this is the x plus h form. So I'm telling the function right here is this right here. So that's something that we're going to be using later in the chapter. So I just want to make sure you note that form here. So for this one right here, it's f of x is the first one. So that's going to be my function there. So just being able to tell, so using this form, here's my function. And if I'm using this form, here's my function here. So right here, all you would have to do is to cancel. So that cancels. The 3 x's cancel. The 1's will cancel. So I'd be left with 2xh plus h squared plus 3h. Pull out my h from everything. So I'd be left with 2x plus h plus 3. Plug in 0. So then my answer should be 2x plus 3. So over here, combining my like terms, I'm going to end up with, let's see, limit as x approaches 2. That's x squared plus 3x minus 10. So I got to factor that top. So x, see, plus 5 and a minus 2. My 2's cancel. So I just plug in the 2 at this spot now. So 2, oh, sorry, you're off the screen. So plug in my 2 at this point. 2 plus 5 equals 7. So the answer to number 2 is 7. So down here is just some notation. All of these mean take the derivative, and it depends on what book you're using, what professor's teaching it, and whatnot. Most professors love this notation because it tells us the most information. So it's saying that I took the derivative of y with respect to x, and we actually have to use that later on in the chapter. Y prime is really like just the lazy man's method, saying that you took the derivative of the y. This is also a very lazy notation. It's saying we took the derivative of the function, same thing. And then this is just we're taking a derivative of some function with respect to x. So typically what we will see though is this, but all of these notations are all fair game for you to have to learn for that.